The first expression in partial fractions, expand in ascending powers of x up to and including the term in x squared. State the range of values for x for which your expression is valid. So it says by first expressing in partial fractions, of course here, right, you would need to do that, right, before you expand using the binomial expansion, because you've got all these x's on the top. So what we do is, by partial fractions, we set it up as we normally do. Okay, so you've got a over 1 plus 3x plus b over 1 plus x plus c over 1 plus x all squared. Okay, so then we multiply through by that bottom here, so we get 2x squared plus x plus 1 here. So you get a then, so if we're multiplying through by this, the 1 plus 3x will cancel here, so you get 1 plus x all squared. Here we've got b, well, 1 plus 3x, and then 1 plus x, okay, is left over, and then because you've got c 1 plus over 1 plus x squared, 1 plus x squared cancel, so 1 plus 3x there, okay. So then we'll set x to equal minus 1 to start with, maybe. So then this becomes 2 times minus 1 all squared plus minus 1 plus 1. Put minus 1 in here, well, the a will go, the b will go, and the c then will be 1 plus 3 times minus 1. So work this out on your calculator, and you get 0, I think, is that right? Let's just check late in the day. No, you get 2. And then here you get minus 2c, okay? So that means then c is equal to 2 upon minus 2, which equals to minus 1. So then we set b to equal, so we set x to equal, now 1 plus 3x, we want to make that 0, so we have to set x to equal minus a third, okay? So then we chuck that in, 2 times minus a third squared, minus a third plus 1. So in here then we'll have 1 minus a third squared, okay, for this one. They'll cancel there, they'll cancel there. So get my calculator. This becomes 8/9. That becomes 2/3 all squared, so that'll be 4/9. Okay, so then you can get your a's. A will equal to 2. Okay, now to get the value for b, now there's no other value, we can set x here so that these eliminate. So we set x now to be 0. Set x to be 0, well, all that will go, so you get 1 here. That then will become a. This will be b, and then in the first bracket you got 1, in the second bracket you got 1, and then you got plus c then, and that's going to be just 1, isn't it, when x is 0. So 1 equals a plus b plus c, so 1 equals a is 2 plus b minus 1. Okay, so then that means b is 0. Okay, b is actually 0, I believe. Yeah, that's right. So final answer then of partial fractions will be 2 over 1 plus 3x. b is 0, okay, and then c then is minus 1. Okay, so that's our answer there. So then we've done all this now. It's taken me about 4 minutes to do this. So now I've got to expand this using the binomial expansion, okay. And it does say then up to including x squared, right? So you can see I've got 2 expansions to do, right? So we'll start off with this one. Now we can rewrite this, of course, as 2 bracket 1 plus 3x to the minus 1, right? Take it up, and we can write this one as minus 1 plus x to the minus 2, right? If I take that up there, right? So then we'll expand both. There's quite a bit of work involved, but perhaps what I'll do, just to speed things up a little bit, I'll just go with exactly what I've got here, and we'll keep it all in one line if possible. So we've got 2, so put it in a big square bracket, there's a 2 there, so let's expand this here now. So there'll be 1, plus then minus 1 is the power, times then x, which is 3x in this case, plus then n, which is minus 1, times then n minus 1, which is minus 2 over 2. And you've got square x, okay? So there's that expansion there. Take away then the expansion of 1 plus x to the power minus 2. So then we maybe put this in the square bracket as well to help us see things clearer. So you've got 1, and then minus 2 is the power, so minus 2x, that's easy enough. And then you've got then minus 2 times minus 3, because n minus 1 is minus 3, over 1 times 2, which is 2x squared. Okay, so just about fit that in there. So simplify this, 2, 1 minus 3x. This here becomes 9x squared when you work all that out. Okay. Take away then, in this bracket, 1 minus 2x. This then becomes minus 3x squared. Okay. Multiply out then that square bracket, 2 minus 6x plus 18x squared, so multiply through by 2, and then take that minus through here, minus 1, minus plus 2x, minus then the minus 3x squared is plus 3x squared, and put that together then, so you get 2 take away 1 is 1, minus 6x plus 2x is minus 4x, 18x squared plus 3x squared is plus 21x squared. So finally we've got there with that, right? And then it says, of course, what is the series expansion? What's it valid for? Now, we expanded two binomials here, right? So you've got to look at both expansions. So 3x is less than 1, okay? And also, right, you've got this as well, mod x is less than 1, okay? So in this case now, mod x will be less than a third. And also, mod x here is less than 1. We've got that. Now what you've got to do is you've got to choose the smallest one, okay? Because if you choose the biggest one, then this one here, for instance, it will contain certain values that are not valid in here. X has got to be less than a third here. So if I pick 2/3 in there, which is acceptable, it won't be acceptable here. So you choose the smallest one, so that one. So you say, therefore, mod x is less than a third, which of course implies then x is less than a third, okay, minus a third. Okay, and we're done.